Welcome to Why Should I Invest? Developed by the International Collegiate Angels Network, or ICAN. At ICAN, we believe that campus-born ventures are today's most underappreciated asset class. Each podcast will spotlight a campus-born founder and the venture they're building. I'm going to ask the tough questions that investors would want to ask. And welcome to Why Should I Invest? I'm Dr. Tom Duening. Today I'm here with Dr. Linxi Shi, and she has a company called NeuralTrak. She's the CEO and founder. NeuralTrak developed low-cost, low-dose 3D imaging to simplify surgical guidance using physics-informed AI. And it's a delight to have you on our show today. It's a very interesting technology. I very much look forward to our conversation. Please tell us a little bit about yourself and how you came up with the idea for the company.
Thank you so much for the introduction, Dr. Duening. I can start with some introduction. NeuralTrak was born out of a deep frustration I experienced firsthand as a medical imaging scientist. So I spent years doing the research at Stanford in cancer imaging and earlier trained as a medical physicist at Georgia Tech. So I saw a recurring problem, which is advanced intraoperative imaging like the CT or the O-arm was powerful, but they're too expensive, too bulky, and too complex for most of the surgical settings, especially for the outpatient setting or the small hospital to medium-sized hospital. That's the majority of the procedure are shifting to. Surgeons were forced to rely on only the 2D x-rays and the mental mapping during the high-risk procedure like the spine fusion. So the gap really stuck with me. So that's why I started NeuralTrak, is to solve it, not by building more expensive hardware, but just by transforming the existing 2D CR machine into an intelligent 3D guidance system using the physics-informed AI. So I think my mission is to democratize the surgical imaging and bring CT quality navigation into every operating room that need it. That's pretty much it.
That's well said. It's very, very interesting. And your background, I think, clearly makes it that you are in the right place to create this company and to operate this venture and to generate this technology with the physics background. I do see that you're in a SBIR phase 1 project with your company. Tell us a little bit about that.
Exactly. So NeuralTrak is actually a Stanford, Connecticut company. So I did my postdoc over there. And actually last year, we initialized this company. And so we applied for the NSF SBIR phase 1 program, and we get it. So Stanford is also part of the sub-awardee of that. That's the kind of the collaboration. So I think we got the grant last September, and it will be towards the end of the August. So the next step is we're gonna targeting at phase 2 of that, which gonna happen probably early next year. So in the middle, we probably need some bridging funding, just to bridge the gap.
Right. So what did your phase 1 achieve?
So basically, the goal of the phase 1 is just to finish up our engineering prototype, which is ready for the basic clinical testing. So where we're collaborating the spine surgeons at Stanford and the UC Irvine Medical School. So towards the end of the next month, actually 1 month before the end of the SBIR, we're gonna get the prototype ready and then start our testing on cadaver and phantom study.
I see. Okay, so you're at the phase now where the prototype is getting ready to be implemented, and you're going to start collecting data on that within like a couple of months, right?
Yes. So that's going to be a couple months that we figured. This is only the engineering prototype. So we need a lot of iterations, I guess, just to try to really have our clinical prototype. For that, we're going to collaborate with our surgeons. They can help us to build the UI UX platform.
Right.
In the meantime, we can acquire the data, and then for us to do the retrospective study.
Okay, cool. And what do you expect to do in the phase 2?
So phase 2 is more on the commercialization side and also the FDA clearance. So the goal is before the phase 2 starts, we want to have enough data to be collected for the FDA clearance. From my understanding, our FDA pass will be 510K, where you need to show that your image quality can match a predicate scanner, which there's many out of there. Yeah.
Yeah, it's a fascinating technology, and a little bit is, of course, over my head. I'm not in the physics AI space, but tell me a little bit about, I mean, the fact that you can use standard equipment that is available in clinics today and generate 3D images using, well, you call it the physics informed AI. Tell us a little bit more about physics informed AI.
Yeah, so that's actually really where our expertise come in, the CT physics and the reconstruction. So as you know, like in order, excuse me, in order to get a CT images, the X-ray source and the detector has to rotate around the patient for 360 degrees. So that's really a lot of radiation, and you have to do that in order to do the deterministic reconstruction. So what we can do here is we can use the physics-informed AI idea to taking only 60 to 90 degrees of the data, and then you can reconstruct the fully 3D images. The reason why we say is different is physics-informed because it's not trained only on data. So you have to understand the physics of how the X-ray interacted with the patients.
Right.
What kind of artifact it actually generates. So all the beam hardening and then this X-ray scatter. And also when you're rotating the system, how the system actually, the relative pose of the system to the patients, how do you calibrate that? Because it's not a dedicated CT, so you will facing the problem of geometric calibration. How can you do that in real time? So that's the work really built into the AI neural network for them to train. Okay, here is how the physics actually really kick in, and then so with only the data from the shelf, you cannot do that.
Right.
So that's why we say that's going to be the physics-informed AI. So basically, for this scenario, the surgical scenario, we build every physics component into that for the image formation. For the team to build that, you can't just know AI. You have to know the medical physics. You have to know how the image is actually formed.
Right.
So that's basically where the physics kick in. Yeah, that requires a highly skills in terms of the simulation and then how to simulate Monte Carlo simulation, how the X-rays actually interact with patients, and all kinds of the things. So I think we have a unique group to do that.
Right, and this is a software product that you're developing. And what I find interesting about it is that you're already thinking ahead of the clinical applications, and you realize that in order for you to be able to sell this product eventually, that in the clinical environment, they want to maintain their current workflow. And your product is going to just sort of integrate into the current workflow patterns and not be wholly disruptive of that.
Yeah, that's right. So this is really all these ideas is just starting with interacting with the surgeons, interacting with all the residents to see the pinpoint. And I feel like, because they say we need 3D images, but we don't need such 3D images because it really interrupts our workflow. It's adding up the procedure time to 50 minutes. Each minute costs $50. And then if you have 50 minutes adding up, it's going to be $2,500. The whole reimbursement for a certain procedure probably less than $6,000. But so that's why this every minute, every second actually counts. That's really, I want to do something not to interrupt with the workflow. That's exactly where I'm really trying to do. And then, shadowing all the procedures and really see the pinpoint, something I want to solve it.
Well, I find it fascinating that you're already thinking about the sales process and the sales cycle in the clinical environment. And all the impediments that are going to occur, right? Because the typical surgeon and the buyer in the clinical environment is probably going to be a little skeptical of physics informed AI, and certainly whether or not it's going to be a lot of training involved, and for the staff, and whether it's going to upset the workflow. So you're already thinking ahead to how it is that you're going to be able to distribute this product.
Yeah, thank you. Exactly. So in terms of the distribution, so the idea for this is really, I want to bring this to every operating room. So basically just the ambulatory surgical centers, small to mid-size of the hospitals. So one of the pinpoint for them is like they don't have enough space, and then they don't have enough budgets. So, but all of them have this actually 2D CRM system. By enable doing this, so we can actually bring more procedures into the surgical room, and then also at the same time, once you bring more complex procedures, for example, like the fusion of the spine fusion, the bigger vendors in the implants world can actually sell the implants to ambulatory surgical center, which they otherwise cannot do that. So basically, this is really the channel we want to go to, and how to actually get there. So I think we're going to start because we are from the academic side. So we have strong clinical bound with connection with Stanford, as well as the UC Irvine Medical Center.
Okay.
So one feature of these two centers, they have a massive satellites ASC center. So for example, at Stanford around here, you can find 30 to 50 ambulatory surgical centers, small hospitals around this area. So my goal is like, we're going to start with the pilot study at Stanford and the UC at Irvine. So we have very strong connections with these doctors. Once they want to adapt our technology, so Stanford and the UC Irvine can be the first adopters, and then it's actually expanded to their satellite ASC center. So that's my current strategy in terms of doing this.
Yeah. No, it makes a lot of sense. Where are you in terms of applying for the phase 2?
Phase 2 application start November.
Okay.
So it takes the 3 to 4 months to get them. So hopefully it will not be delayed. So I'm expecting probably next year around February, March. That's the earliest time we can get the phase 2. Good thing about phase 2 is they have the Series B. So once you raise a little bit, they can actually match, dollar by dollar up to $500,000. So that's my next goal of the fundraising. Probably I have another one, like a pre-A round, and then to get that Series B.
Okay. So I'm trying to understand the roadmap. I mean, there's so many things about this that I would certainly want our investors to know about. And one is that your imaging technology is based upon equipment that clinicians already have, right? The C-arm X-ray machine, X-ray.
Right.
This is a very standard equipment. So this just sort of layers on top of standard equipment. And the alternative, of course, is some very expensive 3D imaging. Tell us a little bit about what the alternative would be if they didn't use your product.
Right. So there's a standard alternative. So for example, like the Medtronic O-arm system and Siemens CO system, GOEC 3D, and the very expensive Siemens robotic C-arm system, or you can even get an intraoperative CT. The cheapest probably will be the O-arm system, which will cost $1 million to $1.5 million. Just the equipment alone, and then adding up like a 10% of the service fee. So that's the must-have. And then plus, every time when you're running the machine, you have to have a dedicated person coming in and then to operate them. So that's actually also add up on the cost. So that's going to be very expensive compared to a typical 2D standard CRM system, which you only like $200K, something like that. But it's only 2D. You don't have the 3D information. But what we can do is really make this system flexible. And then another thing about those 3D information is like the alternatives can provide it. That's every time you have to have a pre-planning. And then during the procedure, you can only get the image for one time. So you cannot change your the volume interest or the center of the imaging. So, but for our method, we can actually take, just a limited angle of scan anytime and anywhere. You don't have to fix at one point. But in terms of like budget wisely, so we probably can provide the 10 times, less in terms of the cost.
And you're thinking about a monthly subscription type model?
Yes, I'm thinking about the subscription model. The rationale behind that is the $10,000 per month is because we know we get the information from surgeons and the hospital. Each spine fusion procedure depends on how many screws you put in there. So the reimburse rate is about, the profit they get after the reimburse is about like $6,000 to $14,000. something like that. That means like if you just do 1 or 2 of the spine surgeries, you get that subscription back. But we are sure, so this is so small volume. So our spine surgeon, our collaborators probably do 4 or 5 each day.
Okay.
So that's going to be a massive volume.
So in your ideal world, right? So investors would want to know, in the ideal world, when do you think we can go commercial with this? When do you think we're actually going to be able to start selling to clinics all over the country, say?
The goal to get the FDA clearance will be the early 2027. So that's our goal. At the meantime, so we want to get the ARB study, cadaver study. So we already built a nice pilot study for, people to see, okay, we get a good track record. That's our goal. Maybe around like the first quarter, 2027.
First quarter. Okay, cool. And my notes tell me that you're looking for up to $2 million on this round.
I'm looking for actually 1.25 million. There's a pre-valuation of 4 million. We have some lead investors. We're probably committed around like 660 to 760.
Okay, you get about half the round. Okay, that's very encouraging. And do you think with the phase 2 and with the 1.25 that you're going to get through to the 2027 launch?
I think so, yes.
Okay, great. Well, we have a very limited time. Is there anybody, can you tell us a little bit about the other folks on your team?
Yeah, so the team really comprised of a lot of CT experts. We are CT, we know CT physics, we know AI imaging, including myself. And then for myself, I actually spent another 3 years at another startup before this.
That's good.
This journey. So I'm a scientist lead at a Reflection Medical. I don't know if you've heard about that, which is a PET-guided radiation therapy. So I'm on the product development side, went through all the FDA clearance and then understanding from the prototype and then to commercialization side. So that's myself, the background of myself. So we have about 3 engineers, and also one business development person from Wharton, and then has a very seasoned business development marketing person, doing medical device and the biopharmaceutical. And then we have another advisor for the imaging commercialization as well. And then we also have a medical advisor board comprised of 4 to 5 surgeons who are really excited about this technology. We'll do the pilot study.
Great team. That sounds great. I have been to your website. Your website is NeuralTrak, TRAK.com, NeuralTrak.com. And there's contact information there, correct?
Yes.
Yeah. Okay, great. And I wrap up every one of these episodes with the fundamental question, why should I invest?
So I think, it's a great question. So I think right now, we're really excited about the momentum we're building and the opportunity to really transform surgical imaging. We can starting from the spine surgeries, but it's actually really, really applicable to all kinds of the surgeries. So at this moment, I feel like there's a really big gap between what the hospital can afford for and what's the industry is building. All this robotic system, AI with AR, VR system. Yes, they're nice technology, but there's a gap actually. You can really use imaging to build them. So we're really build a upstream solution to guarantee the accuracy and the precision of all kinds of the surgeries down the road. I think it's a great team, and then it's a great opportunity. And then to do this, especially with all the procedures right now, is trying to shifting to the smaller and to mid-sized hospital.
Great. Well said. Thank you so much. It's been a pleasure speaking with you today. Wonderful technology. It's NeuralTrak. It's at NeuralTrak.com. And I've been speaking today with Dr. Linxi Shi from Stanford. Thank you so much for being with us today.
Thank you. Thank you, Tom.
For more information about how you can get involved in the ICAN mission, please contact me directly via email at tomdenning@icanhub.net.